students, today we will solve the exercise 1.2. Before this, we have to see some concept which is related to this exercise, real numbers. Okay, you are seeing here I have mentioned real numbers. Real numbers are number which we can easily plot on number line. Okay, and there are two real numbers. This is the two parts of real number. First is rational number, second is irrational number. In our previous video, we have gone through with the representation of rational number. Today we will see representation of irrational number on number line. Before this, we have to know Pythagoras theorem, which you have already studied in your previous class. Okay, we have plot, this is a right angle triangle you are seeing here. Okay, this is the perpendicular, this is the base, and this is the hypotenuse. Okay, this is the 90-degree angle. Just in front of 90-degree we have marked the hypotenuse, which will join our base and perpendicular. And the theorem having a formula which means hypotenuse square equal to base square plus perpendicular square. Okay, now just see the one example of the irrational number. Root 2 is irrational number. So how to draw root 2 on number line? We just draw a number line. We have marked this origin 0. Now hypotenuse square equal to base square plus perpendicular square. If we will break it into this form, this will be 1 square plus 1 square, which means 2. So h equal to root 2. Okay, so this is our origin and we will draw it in equal parts. Okay, in graph we will take each block is 1 centimeter. Okay, so we just simply draw a 1 centimeter distance here. Okay, and we take a perpendicular of 1 centimeter with the help of protractor. We draw 90-degree with this point and we mark a 1 centimeter here. This is 1 centimeter long. Okay, we join these both points. So according to Pythagoras, this will be hypotenuse of measurement root 2. So we just mark it root 2 here. Now we will take, this is the center point and this will be the radius, and with the help of compass we just draw an arc. We draw an arc like this and we will get this point. Okay, and this point, if this measurement is root 2, so this is also root 2 with the help of geometric concept. We found this measurement from the origin and this long distance is root 2. Okay, now we will see how to draw root 3 on number line with the help of same concept. 3 on number line. Okay, and we have already drawn root 2 on number line. We know the position of root 2. So now by Pythagoras theorem we will break it in the form of that. So hypotenuse square equal to root 2 square plus 1 square. We can break it like this. This will be 2, this will be 1. So hypotenuse equal to root 3 and we have to find it. Root 2 position we have already mentioned here. We have already drawn. Okay, now we just take a 1 centimeter perpendicular on the position of root 2 with the help of protractor. Okay, now we just draw a line with the help of a scale from origin to this point. This is our hypotenuse and we will mark it √3 according to this. Okay, now the same process we will do this. We will take it as a center point, take it radius of √3 and draw a arc. We will draw a arc here with the help of compass and we will get the point which is also √3 because this measurement is √3. So this will be also √3 from the origin and we will point the √3 on the number line. State following statements are true or false. Justify your answers. So first is every rational number is a real number. Okay. We have just seen that real number having two types. First is rational number and second is irrational number. Right. So rational number are coming under the real number. So all rational numbers are real numbers. This is the true statement. Second one is every point or number line is of the form of √m, where m is natural numbers. Okay, to find out the root of any number, the criteria is it should be positive. We can't find the root of -4. Is it possible? No, we can't find. Okay, so for that, the number should be positive integer. And on number line, we also draw negative integer like this. So this is the false statement. Why? Because it is saying that every point or number line is of form of √m. This is not possible. Every point or number line is not in the form of only √m. It should be in form of negative integers also, and √m should never be negative integer. It always be positive. That's why here it is mentioned that m is a natural number and all positive integers are natural number. Okay. Now next statement is every real number is an irrational number. Is it possible? No, it is not possible. Irrational number comes under the real number. But how you can say that every real number is irrational number? No. There might be some numbers are rational and some numbers are irrational. But you can't say that each and every real number is irrational number. This is not possible. So this is the false statement. Okay. Now next question. The square root of all positive integers irrational? If not, give an example of the square root of a number that is rational number. Okay, let's see. All positive integers 1, 2, 3, 4, 9. These are the positive integers, right? Just take a square root of all these integers. What we will get? The square root of 1 is 1. The square root of 2, it is not a perfect square. This is also not a perfect square. The square root of 4 is 2. The square root of 9 is 3. So these are the positive integers. These are the rational number. This is also rational number. This is also rational number. So is it possible that square root of all positive integers are irrational? No, because we are finding here the rational number. So this is the false statement. So the second is give an example of the square root of a number that is rational number. Obviously we have given the example. These are the square root of positive integer and we are getting rational number. Okay. Now next question. Next question. Next question. How root 5 can be represented on number line? Through Pythagoras Theorem, we will break root 5. Hypotenuse square equal to 2 square plus 1 square. What we will get? 4 plus 1, which means root 5. Okay, now we will draw a number line, mark the origin 0, and this measurement, base measurement is 2. So we simply mark it 2 centimeter. This is 2. And take a perpendicular with the help of protractor of 1 centimeter. This is 1 centimeter measurement. And we join these 2 points. This is our hypotenuse, which is root 5. Okay. Same, which we have already seen. Take this point center and this will be radius, and draw a arc here with the help of compass. This point which we have found here, that is root 5. Okay, very simple representation of root 5 on number line. Okay student, in next class